Okay. Okay, good afternoon, everybody. Can you hear me? Yes, at the back, brilliant. My name's Claire Ainsworth, I'm a science journalist, and I'm going to be chairing the session this afternoon. And on behalf of the Royal Society, it's my pleasure to welcome you to this event as part of the Summer Science Exhibition. Now, just before we get started, we've got the usual housekeeping things to go through. Number one, please could you make sure any mobile devices are on silent, because nothing ruins the atmosphere like phones going off. We're not planning any fire alarms today, so if you do hear something go off or there's an emergency, the fire exit is located at the back of the room through the doors you came in, okay? So make your way calmly and quietly through there. If anyone has particular access needs, please do make yourself known. Okay, and the last thing to say is we're going to record this event and make it available online, so you can come along and watch it afterwards. So, on to the event. It's based around the idea of a café scientifique. Now, has anyone been to a café scientifique before? Got one here? You guys over there, okay. Well, the first time for a lot of you, I'll explain a bit about what the Café Scientifique is. It was invented back in 1998 by a TV executive called Duncan Dallas, who wanted to find a more interactive way of getting people to get involved with science rather than just sitting in front of a TV. And he was inspired by the Café Philosophique movement in Paris and started running Café Scientifique events across the road from his house in the cafe there. So what's so different about the Café Scientifique? Well, it's not the usual format of expert speaks and then it's followed by Q&A. It's much more about doing away with the lectern, bringing down barriers. We've put you in circles, there's drinks for you to have, and we're trying to break down the barriers or the power relations that usually apply between the scientist who knows everything and everyone else. So it is a very informal event, and the more you interact with us and ask questions, the more you're going to get out of it. So please don't be shy. So the other thing we're going to do is we're going to have a taste demonstration. Okay, so we're going to talk about putting some of this science into practice. So for this afternoon, we're going to ask, why is it that we love, well, many of us love spicy food when it causes us so much pain? Well, in some cases, it depends how hot the food is, I guess. And if anyone wants to tweet about this or follow it, the hashtag is #SummerScience on Twitter, and their handle is @RoyalSociety. So without further ado, I would like to introduce our speakers this afternoon. Here is Professor John Wood and Professor Charles Spence. So John is based at UCL. He's a fellow of the Royal Society and Professor of Molecular Nociception, which is pardon? Damage sensing, or actually the science behind why we feel pain. Charles is an experimental psychologist, and he heads the University of Oxford's cross-modal research laboratory. He consults with various companies and has actually advised Hess and Blumenthal for over a decade. So there'll be lots of interesting stuff about that, I'm sure. So just to kick off, I'd like to first of all invite John and Charles to stand up and talk for about 5 minutes each about their science, and then we'll move on to the rest of the show this afternoon. So I think we'll start with John, because you're going to talk about the pain first, and you're going to talk about why we like it. So off you go.
Thank you so much. Well, this is my first ever Café Scientifique, and with all the intense competition from Gay Pride, it's very kind of you to show up. I'm a bit of a fraud, actually, because if you give me a vindaloo, I would run a mile. I'm one of those people that really doesn't like very hot food. But what I have enjoyed is exploiting the chemistry of hot peppers to understand more about the pain system. So if you look at the history of research into why peppers taste hot, actually this goes back to Christopher Columbus. He noticed that all the natives in North America are actually eating very, very hot chili peppers and brought some of them back to Europe. But it wasn't until the 20th century that some Hungarian pharmacologists discovered that the active ingredients in chili peppers could activate peripheral nerves. And so there was some kind of interaction with nerve cells. So the structure of the active ingredient, which is called capsaicin, was worked out in the early part of the 20th century. It's just a big aromatic ring with a sort of fatty blob, a long chain fatty acid on the side, and it's got a methoxy and a hydroxy group. It looks like a detergent, and if you remember your school chemistry, you might expect this thing could punch holes in cell membranes. But the school of pharmacologists in Hungary particularly Yansho and Saljani, did a lot of chemistry on this thing, and they discovered that actually there was a specific binding site. So there's some real biological specific activity that was activated by pungent chili extracts. So this was quite interesting, and I spent 10 years of my life actually making drugs based on capsaicin to see if we could make really useful analgesics, and it was an abject failure. I think we spent 80 million pounds on this. So why do you think plants make horrible, super hot toxic compounds like this? Well, it's quite interesting that some of these peppers are known as bird peppers, and all the apparatus that we have for detecting capsaicin isn't present in birds. So the birds will come along, eat the plants, and they will distribute the seeds over a wide area. Whereas nasty little rodents and rats, which actually eat the plants, will chew up and grind up the seeds. So this is a nice evolutionary payoff for the plant in distributing peppers around and about the place and deterring unpleasant animals that might eat them up. So that could be one reason why plants make peppers. So in the 80s, when we started working on this, we showed there's a specific receptor that's present in sensory neurons, and it's associated with an ion channel. So this, when the capsaicin binds to the protein, ions flow into the neuron, and you get action potentials sending signals into the central nervous system. So that seems to be how it works, both in the pain neurons and in the taste neurons that you have in your tongue. But obviously we didn't know what this thing was, and the real breakthrough, I'm not going on too long, give me a few more minutes. The real breakthrough came with some brilliant genetic expression cloning from a group in California. So Michael Caterina, John Levine, and David Julius at the University of California in San Francisco used a sort of calcium imaging technique to clone the gene that encoded the receptor for capsaicin. And when they looked at the structure, they found it was a known class of proteins that had been defined before, and these are called transient receptor potential proteins. So this is called a TRP protein, and these were discovered in Edinburgh about 50 years ago in fruit flies. So it turns out that the TRP channel that's activated by capsaicin is also an ion channel letting in sodium and calcium. And Roger Hardy in Cambridge was the person to show that these TRP proteins were actually ion channels. So it turns out that TRP channels are an amazingly interesting set of proteins. They're involved in almost every aspect of sensation you can think of. Hearing, vision, detection of pheromones, detection of heat, cold, acid, mechanosensation. So these proteins are almost our window on the external world. They're really, really very fascinating. And actually, through studying things like the capsaicin receptor, we've found out a lot more about them. So in order to see what this TRP channel thing, which is called TRPV1, because capsaicin is a vanilloid, a group led by John Davis, who's now at Oxford, made a mouse in which they deleted the gene. And amazingly, the heat sensitivity of this mouse is entirely normal. You might be shocked to hear that. Because although TRPV1, the capsaicin receptor, is activated by heat, there's a whole bunch of other channels that are also activated by heat. So if you lose one, the other channels can compensate for it. And this is recent work from Thomas Wurtz at Louvain, who's found 4 different heat-sensitive channels in sensory neurons, of which TRPV1 is the one you'll read about in the textbooks, but it's not the only one. So what John Davis showed is that actually this channel is very important in inflammatory pain. So if you've just been playing a match with the All Blacks and got kicked on the knee, you protect that area. That's called inflammatory pain. And TRPV1 is involved in that type of sensation. It's activated by low pH, which is a characteristic of inflammatory pain. So the big question for us today is, capsaicin and TRPV1 are clearly involved in pain sensing, and they're also involved in tastes associated with curries. How is it we can love curries, and yet this compound is pain-inducing? Well, I think the answer is, or shall I wait till the end? Or shall I tell you now? I think the answer is that if you look in the tongue, you look at the taste buds, you find these gustatory neurons have got a very small surface area exposed to the external environment, and they have TRPV1 on it. And then around them are a whole bunch of these damage-sensing neurons, which also have TRPV1 on, which will tell you when your coffee is too hot. And it's the relative balance, the interplay between the pleasurable sensation through the taste neurons going up to the gustatory cortex and the activation of these neurons that normally respond to tissue damage, which decides if you're a wimp like me. You know, I just had a biryani last night. It was the most I could do. Or whether you're a He-Man like Charles, who is Mr. Vindaloo Special. And I think it's this balance which actually explains why we can eat curries with a pleasurable experience, but at a certain cutoff, it starts to become unpleasant. Over to you, Charles.
That's great. Well, that sounds like there's a very fine line to tread between pain and pleasure. Yeah. So I think Charles is going to tell us a little bit more about that.
Okay, so I'm a psychologist based at Oxford who spent years interested in the senses, how we see, hear, smell, touch, taste, and feel pain, and occasionally pleasure, but more often pain. And I'm also interested in food and flavour, hence the new book, Gastrophysics, which is all around the senses and the enjoyment of food. So kind of chili sort of sits there right naturally at the intersection of pain and the pleasure of food, and probably a good place for me to study. In the old days when we were looking at pain, we'd stick people's arms in ice baths and measure how long they could stick it in there without having to pull it out. We'd put lasers onto people's arms and burn them a little bit, and again see how intense the pain was. And occasionally we'd rub capsaicin into the skin and again see what happened. And look at the impact of colour. If I tell you it's going to hurt a lot, will it hurt more than if I tell you it won't hurt at all? If I change the colour of the laser beam to red, does it hurt more than a blue laser beam? Yes, it does. And if I release a sweet smell like strawberry, can you keep your arm in the ice bath for longer? The answer is yes, you can. Sweet tastes and sweet smells allow you to endure pain for longer. But in recent years, we've moved more to the world of food. And kind of initially, when you look at food, you start with this simple stuff, kind of what you can taste: sweet, sour, salty, bitter, maybe umami, the fifth mysterious taste. And then maybe at flavours, the stuff you get from your nose, the fruity, floral, meaty, herbal, burnt, creamy, and so on. And when you've done everything you can with them, then you sort of think, what's next to do in the world of flavour? And it's these unusual sensations that come in, like creamy and spicy too, something that is not studied a great deal. In part, 'cause it's kind of hard to give your subjects lots and lots of chili peppers and see how they respond each time. They'll be out the door before you know it. So it's much harder to do the research, not to mention the ethics involved. And yet it's a really interesting kind of part of our world of taste, mouth experiences. For me, because it sort of sits there somewhere between, well, my colleague here referred to it as a taste. And if I was with my philosophy friends, they'd be hitting him over the head already and saying, you can't say that, because a chili perception is not a taste, it's some other kind of maybe damaged sensitivity, but it's unlike the other basic tastes. So it sits in an interesting place there. And it's interesting to us because of the difficulty of sort of studying it in an animal model, as Paul Bloom says in his book about how pleasure works. You know, we're the only ones who would ever eat Tabasco sauce. No other creature does, and as such, it's a little bit harder to understand what drives pleasure if you've only got humans to look at. It's interesting because of the huge individual differences between those who hate chili burn and others who crave it, who love it, who can't get enough of the vindaloos and the spicy stuff. What determines that individual difference? Is it all culture? Is it physiology, genetics? Is it just, you know, those boys trying to be macho and taking the heat? All have been proposed as explanations, but I think it's something that we really do need to think and study more seriously, both to explain why it is that in only 500 years or so, you know, chili's taken over the planet, and there are so many kind of cuisines from parts of the Indian subcontinent to Thailand where you couldn't really imagine their food without chili. What would it be like? Well, it wasn't there 500 years ago. It is there central today. So what determined that kind of transition and rapid growth around this? My suspicion as to why we like it is rather building on the work of Sherman and Billing, who've got a great paper on, what's it called? The evolutionary gastronomy, something like that. And their suggestion is that many spices, including chili, have antimicrobial properties. You'll find them, those spices, like chili, in much greater preponderance in the cuisines of countries and cultures where the ambient temperature is higher, where meat's likely to go off sooner. And it's that, for that reason, that the antimicrobial properties of chili will result in the food being a bit safer for you to eat, and you'll like it a bit more than other food without the chili that makes you ill because of all the microbes and the bugs and the other stuff. and that's why we come to like chili and the other spices. More than that, I can't really say, because there are some things going on next. I don't want to give away the punchline, if there is one, but that's pain and pleasure in a chili.
Fantastic, thank you very much. Well, that's both fascinating talks, and you'll have plenty of opportunity to ask lots of questions. But before we get on to the questions, we just wanted to do a little experiment to see, how can you, get you to experiment with the science of hot food. So what we need are 3 volunteers who aren't scared to have a little bit of heat. Okay, how about lady here? You? One here, one at the front.
Volunteers, you said.
Lady at the back there. Want to come? One more. And I think just for the gender balance, are there any blokes who think, yeah, I can take a curry? Yeah? How about gentlemen here? Do you want to come up? Okay, brilliant. Thank you very much. Okay, so have you got a microphone so we can hang a moment? We just need to have a quick chat. So find out who everyone is. Have you got a mic? Mic? Pass me the mic. So what we need to do, have a quick chat. So what's your name?
My name's Andy.
Okay. And do you like hot food?
Yeah, I like chili, yeah.
That's chili. So any particular cuisine in particular that you like?
I can put chili on pretty much anything, actually.
Okay.
Got a little bottle of chili oil on the shelf in the kitchen, and if something just isn't quite chilied enough, get a bit more on there at the end on the plate.
Okay, so you're definitely someone who likes it hot then?
Yeah.
Fantastic, Andy. Thank you very much. How about you? What's your name?
Clary.
Hi, Clary. And do you like hot food?
Well, yeah, because I like Indian food, and my parents have basically raised me on chili, so.
And what's your favourite dish?
I do like a tikka masala and biryani, so.
Okay, brilliant. So a broad taste there. How about you? What's your name? Sorry.
Tatiana.
Tatiana. And do you like hot food?
Not really, that's why I wanted her to go.
Okay, and what don't you like about it?
Well, it's just more painful than pleasurable.
Okay. Okay, we've got. If you went to a curry house, you'd have a korma rather than anything hotter.
Exactly, yeah.
Okay. Okay, brilliant. Well, we've got a nice mix of people here. So what we want to do for the first part of the experiment is, we've got some solutions here containing capsaicin. Yep. and what we want to do is we have. So we've got three sets of experiments to go on here. We've got a clear solution here that we're going to get you to taste. You can either drink it or spit it out in the bucket if it's a bit too hot for you. And the one in the middle here, where there's no music being played, and one on the end where we've got yet another kind of chili. So we've got blue, red, and clear. Music, no music, and calm music. This is quite sort of exciting music, isn't it? Is it? Different music. It's different music. And what we'd like you to do is have a go at tasting these, and then move along one, and then move along one. And what we want you to do is tell us which one you think is the hottest. Okay? You ready? Yep. When you're ready, please take it away. Sorry? 10 seconds. Okay. Swish it around for 10 seconds. Around your mouth. Okay? We're not too sure about it.
All right, we'll just spit out your pen there.
Yep.
Yeah.
Okay. Yep.
All right, you done? Okay, that's fine. Put it
Okay.
into there.
Right, you move on to the next one.
Right, just if you want some water.
Okay, while they're doing that, we can ask a few more questions if you like. So, capsaicin. Why did well, either of you? How long have people been putting chili in their food? You know, who was the first sort of person who thought, yeah, that's great. I mean, it might burn my mouth, but I'm going to put it in my food.
Well, I guess Red Indians were doing that in North America when
North
Columbus
America.
arrived in 1490.
Okay.
And I'm not sure about where the origins are in Asia. Do you know about that?
No.
And the Mayans were using it as a medicinal use as well as,
Yeah.
I guess, culinary.
Okay. And there's some sort of odd combinations as well, because I think you can buy chili chocolate, can't you? Which struck me as being quite an odd combination.
Yeah, that's interesting. I mean, many of the foods that we associate with quite intense flavours actually act through these trip channels.
Right.
So there's a trip channel for menthol, you know, there's something for garlic and so on. It's quite interesting. So this is a kind of unifying theme in terms of some aspects of taste. And I guess these receptors must be on the classically defined subsets of taste neurons and sort of tickle different ones. And that must be something to do with a pleasurable sensation.
And I guess I suppose you put chocolate in your chili sometimes if you watch some of this TV cookery shows. So it's natural to put the chili in the chocolate the other way around, perhaps.
Okay, yeah.
And that some would say, if you introspect on where you experience the chili burn, they claim you don't feel it all over your tongue, but it sort of feels more towards one part than another, suggesting to some that there might be some asymmetry in the.
Actually, one of the active components of chocolate, anandamide, is a very weak agonist of TRPV1. Oh. So in a way, chocolate and chili are also physiologically related.
Okay, so natural bedfellow. Okay, that's great.
All right. They've all tasted, they've all tried all three.
You can't hear. Okay, can you hear me? Okay. Okay, well, we're going to sort of just look at the outcome of the experiment. So, volunteers, which solution did you think was the spiciest? The clear one. Okay, so what was the clear chili extract solution, and that had quite sort of, how would you describe the music?
Bang bang music.
Bang
bang music.
Bit of techno pop there. Okay. Right then. Well, that's really interesting because the reveal, of course, is that the amount of chili in each of the solutions is in fact exactly the same. That's kind of weird, isn't it? So the only thing that differs between the samples is the colour. So we had one blue, we had one red, and we had one clear. And the music, we had calm music and we had agitated music. We're just going to have a quick sample of that music now. This is the spicy music, is it? Okay, what about the calm music? It's very calm. Yes, it's very, very peaceful, in fact. Lovely music. It's drowned out by a helicopter at the moment, but that is very, very restful music. That's really nice. Can you hear that? Very soulful. Okay. Okay, well, if you don't mind hanging around near the front just for a little bit, because we've got a second half of this experiment, okay, if you don't mind. I do have a little seat, because I just wanted to hand over to the scientists and say, well, this is really weird. How does that work then? Because we've got exactly the same concentration of chili in these samples, and yet one tastes hotter than the others. Why is that?
That's right. So there's two things going on, I guess. We've got the colour on the one hand, and separately the sound, and those things have been looked at in separate experiments but never together before. And what you find from my colleagues in California, or when they show you pictures of salsa, if they ramp up the redness of the salsa, you expect that salsa is going to be spicier. And then when you come to taste that salsa, if it's more or less what you expected, that red colour does make things taste spicier than normal, but if it's a very suppressed or dark colour instead. When it comes to drinks, it's a bit harder to say because you don't really have very many spicy, that looks more like a sweet drink than a spicy one, or a medicine, I guess, cough syrup or something. But it's a red in food leads to spiciness. And on the soundtracks, we've got the spicy sounds actually been specially composed from really from a series of experiments we've been doing in Oxford and in Nashville, Tennessee, where we give people like virtual keyboards and they can play tracks and change the tempo, the pitch, the speed, the loudness, the distortion of what they're hearing until they find the sound that kind of matches spicy taste. So we find when we give people that virtual keyboard, they'll pick more distorted, faster tempo music and higher pitch music as being spicy. And And then when you take those findings, pass them to a sound designer, Steve Keller from Nashville made that soundscape. The most spicy sound we've got so far. We've got music for sweet, for sour, for bitter, for creamy, and this is the new spicy music, just came out a couple of months ago. And we've been playing that spicy track to diners in a restaurant in Nashville, giving them a spicy mango salad in the restaurant. And some people got to eat that salad while listening to the spicy track. Others got to eat the dish while listening to something like this, the calming track. And again, they too said that the spicy mango salad tasted spicier with the spicy music rather than the other music. So I think there really is a spicy sound. When you hear it, it kind of sounds a bit like what you might hear in an Indian restaurant, to me at least. And then you think, is it coincidental, the kind of music you listen to in some of the places in the world where spicy food is consumed, or is that a non-arbitrary relationship? But that's probably for discussion. So here, I guess what we'd say is maybe the sound won over the colour. Maybe if we'd had the red drink consumed while the spicy music was playing, maybe it would have been the spiciest hit of all. Who knows?
Well, sounds like that's fascinating fodder for discussion. Well, I think we'll come to it afterwards. But we've just got one more experiment to run before we sort of open the discussion to the floor. Now, have we got any more volunteers? I think we've had the first three. Would anyone else like to volunteer to attempt the chili? Okay, gentleman at the back there. I need two more. Lady at the front here, and yes, the lady. Right then. So do come up to the front. That's great. Come and stand here. Tell us a little bit about yourselves. So hi, what's your name?
I'm Jenny.
You're Jenny. And do you like spicy food?
Yes.
Okay. And what sort of spicy food do you like? Is it curry or chili? What's your favourite?
All rage.
Okay.
Asian food, anything.
Okay, so big hot
like
food.
The gentleman before.
Yeah.
Just add it to it.
Big hot food fan here. How about you?
Yeah, I like spicy food as well.
So what was your name?
Pramod.
Pramod.
Yeah.
And what kind of spicy food do you like?
Anything with chilies. That's, yeah.
Okay. Chili lover, excellent. Hannah, what's your name?
Irina.
And do you like spicy food?
Actually, no, I'm more of a sweet tooth person, so don't like spicy food.
Okay, well we've got quite a test for you here then. What we've got, you've probably heard that if you go to a curry house or something like that, you enter in some sort of bravado type competition with your friends about who's going to the hottest food. You taste it and think, oh God, that's just too much. What can you do to neutralise the effect of the chili that you've so recklessly ordered? So what we're going to do is ask our volunteers to put three possible chili antidotes to the chest. The first is milk, the second is lemon juice, and the third is a mint extract. And we'll get our volunteers to test all three, say which one they think has worked, and then we'll try and have a look at why. Okay, so off you go.
As you want.
Okay, so we're trying the chili first. That's a chili solution. Is it quite hot? Yeah. Yes. So, yes, you think it's really, really hot. You're like, yeah, it's fine, I can take it. Okay. Trying the milk antidote now. Not a good combo with chili? No, it doesn't taste too great. Okay. Okay, so we're going to try lemon juice next. So you need the chili first, I think. Yeah, antidote. Lemon juice. Okay, it's like cocktail time here. Okay, and the last one is mint extract. Mint. Mint. Okay.
It's nice, but it doesn't help.
Yeah. Okay, so let's have a vote. How about you? Which one did you think worked the best?
I think the milk.
Okay.
But I like the combination with lemon. That was really nice.
Okay, so from a gastronomic point of view, the lemon was great, but the milk was the best at sort of taking the heat away from the chili. Okay. How about you? What do you think?
Yeah, for people who do need neutralization, so I think milk works best.
Okay.
Who want to enjoy, perhaps lemon is a second act. It's
Okay.
actually a thing in South India. Yeah.
Brilliant.
Yeah.
Oh, I didn't realise that. Well, that's useful information. Thank you very much. How about you?
I'd say lemon worked best because it just made it all sour, and sour is much more manageable than hot.
Okay, great. Well, thank you very much. Please have a seat. Well, thank you. Big hand to all our volunteers for being brave. Okay, so what's going on there? John, is this your department?
Well, I think I can make a stab at it anyway.
Okay.
I mean, the milk is full of protein, and the protein is probably soaking up quite a lot of the capsaicin that's in the chili, so that would stop it working.
And why does it do that? Is it just is it
Well, it's just a
sticky?
physical. It's just because it's a hydrophobic nature of capsaicin, and the fact there are lots of proteins with hydrophobic clefts in, so it just
So it
hoover
sticks.
it up.
Yeah, okay.
Sticky. Yeah.
It's like a sort of invisible sponge. You
Yeah,
just
exactly.
sponge it all out your tongue. Okay.
Now, the lemon juice is interesting because that's a low pH. That's a little bit acid. And acid is known to activate the TRPV1 receptor. But maybe with lemon juice, where it's really low, like pH 2, pH 3, actually desensitizing the receptor a bit.
Right.
And so that also would cut down the activation.
And what do you think about the observation? Actually, in some countries, you have chili with lemon to sort of enhance the.
Well, that's a Mexican
experience.
thing, isn't it? Maybe that's to make it even hotter. Yeah, it's possible.
It gets into sort of flavour pairing that you
Yeah.
recognise that combination of two
Right.
out of three things, and people would say maybe most food cultures you can say there are kind of three core ingredients or flavours that will comprise most of the dishes. So if you've got chili and lemon and who knows what the other one is, coriander or something, then
Yeah.
you're in a certain kind of a bit of space.
Okay.
That's what.
That's great. And how about the mint?
Man, that's really interesting because that activates one of the receptors that's sort of implicated in thermosensing as well, but
Okay.
basically cold. There may be other things in the mint as well, but how the heat and the cold pathways intersect, I'm not too clear. But you can imagine that there's some neutralizing activity
Okay.
caused by activating the cold receptors too.
Okay, great. So the recommendation is if the curry is too hot, milk will actually save your tongue best. Or
I'd always heard you should have a bread.
bread.
Well, it's
Okay.
something like if you hurt yourself elsewhere in the body and kind of rub it to kind of almost kind of gate the pain.
Okay.
Whether the same thing if you have a big piece of bread in your mouth, you can't really chew it. It's sort of massaging your tongue, and that
Okay.
might. I don't know if that's why it works.
Okay, great. Okay, well that's brilliant. Well, thank you so much for that. Okay, what we'd like to do now is see if anyone has got any questions, anything that the speakers have talked about, or any questions that have been prompted by our demos here. Has anyone got anything they would like to ask? Don't be shy. Okay, great, we've got some questions. So, lady at the... we'll take that lady there and then the lady over here afterwards. Okay, there's a lady over there in the... Okay, what's your question for the panel?
What is the relationship between sensing the heat of chilies on your tongue or in your mouth versus those of us who prepare the food and have to chop it and sometimes end up sleeping with our hand in ice water?
Good question. What's the difference? What's the difference between your hand and your mouth in terms of sensing?
Well, the receptor that's activated by the chili is also activated by heat, and that's why you have a perception of heat. But if you get chili over your hand, I guess it's going to keep those pain sensing neurons running all through the evening. And so that's why you have to try to shut down the activity by putting your hand in some ice or somehow interfering with the constant peripheral drive into your brain that's telling you you're undergoing some kind of tissue damage. So I would advise you to wear gloves in future.
Good plan. Okay, how about this question?
My husband really likes chili food and I don't. So whenever he cooks, he puts a lot of chili in the food. And over time, I kind of find myself more desensitized to it. Is that a physical phenomenon or is that a psychological phenomenon?
There's definitely a physiological element to it, kind of capsaicin desensitization that will operate from even just if you just put a paintbrush and just have one sort of brush of capsaicin infused water on your tongue, it starts there. But if you track people over a period of weeks, you do find that the desensitization does build up over time. My wife is exactly the same. I always put too much chili in and she's always complaining about it. We've been married 10 years now, so she's getting there, slowly but surely. Just a bit more time, a bit more practice, and that kind of gradually ramping it up so no one quite realises, each time it's a little bit more, and then before you know it, you've got the kind of health by stealth approach, and she's eating really hot chili now and demanding it when she comes back from holiday as a comfort food. But maybe the danger is it might also impact your ability to taste other sweet, sour, salty and bitter too. And if you saw last year in the Daily Mail, there was a case of the official taste tester for Cadbury's, a kind of dream job, tasting chocolate all day long, and she has her taste buds insured for £1 million on the condition that she does not eat vindaloo and other spicy foods, because it might damage her ability to sense the other tastes.
And just a quick question from me, because I have a similar husband, and he likes putting chili on everything. Is there a sex difference here? I mean, do men tend to prefer chili, more hot food, more than women, and why would that be?
There is, and in some research that just came out from psychologists in Austria, they gave people a big plate full of mashed potatoes and said, here's lots of Tabasco sauce sachets, here's lots of salt sachets. It's a pretty boring dish, just season it yourself. And they found that the endogenous testosterone picked up from the saliva predicted how much of the Tabasco you'd add, but nothing to do with the salt. And that, in some cultures, maybe ours, North America, it sort of goes along with masculine traits and trying to show off, and aggressive behaviours seem to be correlate with increased liking for.
Okay.
Actually,
careful, don't go too far here.
Okay, great.
Actually, could I just say one other point, that if you give a lot of capsaicin, you can actually kill the nerve cell. So you may actually have lost quite a lot of your sensitized nerve cells. And that's another reason why you can eat more and more of it.
There's going to be arguments on the way home tonight, yeah? Okay, well, we'll stop there. There's a question at the back here.
Hello. If you have something very hot and spicy and then grab a glass of Coke or juice to make it better, why does it get worse? At least for me, it gets much worse.
Question for you.
Okay.
So you have the chili at the start of the meal, you've overdone it, and then you have some juice to try and make it go away, but it fails to do so. So I don't know whether that's the acid thing again, that many fruit juices would be fairly high in acid, perhaps. Guess if it's cold drink, then that should help to some degree. But
we don't know.
But having the chili, so now people are getting very interested in trying to get more of us to like chili, because it does seem to have a small but significant beneficial effect on reducing consumption. Both your appetite is suppressed slightly. I think you tend to oxidize more fat as well. So if you're going to have chili at all, they're sort of suggesting have it at the start of the meal, because that will help in terms of you terminating consumption sooner, whereas chili dessert, chili ice cream is probably too late to have that kind of effect.
Okay, brilliant. There's a question here.
Yeah, hi. So following on from the cold point, potentially, I've also been told that beer is one of the best ways of neutralizing heat. Is that purely because the beer that you're having is likely to be cold, so you're just having something cold to counteract the heat, or is there a kind of enzymatic sort of action going on there?
I'm sorry, I didn't hear that. What was
beer? Beer seems to work.
Now, fascinatingly,
Okay.
beer potentiates the activation of the TRPV1 receptor by capsaicin. Alcohol does, but only at very, very high concentrations. So I guess if you're doing brandy, you know, it could be a problem. But if you consider beer to be such a low concentration of ethanol that effect doesn't happen, it's probably just washing the stuff away.
And maybe there's something as well. I mean, it's partly about trying to use what you're drinking to take away the chili burn, but there's also growing interest in pairing food with drinks, and it's traditionally been food and wine, but the beer lobby are getting very insistent. There's no reason why we couldn't pair beers with food. And so if you go to Quilon, one of the Michelin-starred Indian restaurants somewhere just around Victoria Gate, I don't know what direction that is, but pretty close to here, they have an 8-course Indian menu, each course paired with a different beer. Not overly spicy, but they're trying to, by the combination of beer with the dishes they serve, deliver you either an emergent flavour that's neither in the beer nor in the food, or a contrast, or something else going on.
So chili vodka, bad plan, basically.
think so,
Okay,
yeah.
right. That's what's one. A question over here.
You were talking about damage receptors. Does chili actually cause damage? Like, is it just the sensation of pain, or is it actually like in high quantities bad for us? Like, people talk about having trouble the next day. Is that a psychological thing? Does it actually cause damage to like your stomach lining or something else?
Yeah, it causes physical damage to the neuron. It can actually kill the nerve cell. And interestingly, these receptors are also found on smooth muscle. Nobody quite knows why, or what's going on there. It doesn't cause damage to the tissue round and about, but it goes straight for the nerve cell. And in fact, there are some topical analgesics now where they'll give you a local anesthetic like lidocaine and a massive dose of capsaicin just to kill off the ends of the neurons. And that is quite an effective way at treating pain. So capsaicin does cause damage, but just to the nerve, not to the tissue.
And does it grow back? Sorry, does it grow back? Do they regenerate the nerves? So you're not one really massive curry couldn't kill off your tongue forever. Basically, your sense of taste.
I think regeneration is exceptionally slow.
Oh,
yeah,
okay.
yeah.
It's not the taste buds regenerate every 6 days or something?
No, I'm talking about the sensory neurons
Oh,
in the skin and the
the
pain
skin.
angle. Yeah,
Okay.
I mean, I'm less of an expert on what's going on in gustation. Yeah.
And it could be, I suppose, the consequences of chili consumption sort of depend on, or dose dependent. So at very, very high doses, then maybe sort of start to see the carcinogenic properties coming through.
Well, it's not carcinogenic.
Yeah.
It's not carcinogenic. It doesn't cause cancer. It's only toxic. But these guys are using like 40% capsaicin, something even the biggest Vindaloo lover would never get close to, okay? Just to kill the neurons.
Okay, brilliant. Another question.
Is it a myth that hot, spicy foods can help with weight loss?
Okay, I think that relates to what you were just saying, doesn't it?
So indeed they can. They seem to, if taken early in a meal, lead to people reaching satiety, fullness sooner, and so reducing consumption, and also seem to result in a increase in fat oxidation as well. So it's both in terms of reduced energy intake and also increased energy expenditure from chili. And there are a number of groups now trying to get people to like chili more and introduce it in as an aid to weight control.
How big an effect is it? Is it quite a small one or quite a big one? Do you know?
They haven't really done the long-term studies, so it's more bringing people into the lab, giving them a meal with chili or not, either swallowed or orally sensed, and then seeing how much people consume in that one meal rather than long-term studies as yet. But I think they are coming.
Oh, cool. We'll look forward to hearing more about those in due course. Any more questions?
Sorry, following on from the weight loss, is the weight loss really due to increased metabolism, or is it because food passes a lot quicker due to irritation?
I'm not sure the relevant research has been done on that one. Yeah, I haven't seen that in the academic journals, that particular mechanism being worked out in detail, but who knows.
Okay, have we got any more questions for our speakers? There's another question from the gentleman at the back there.
Do you know what makes, like, is it only capsaicin that makes chili spicier? Like, you know, like people say that red chili powder is so much more raw spice than, say, a green chili in something, right? Like, do you know what causes that difference? Is it like, are there other chili-like things in the chili?
There are lots and lots of things in plants that can activate the capsaicin receptor. There's one particularly vicious compound called resinifera toxin, which is found in some plants in Africa. It's 1,000 times more potent than capsaicin. But in different chilies, I think there are compounds related to capsaicin that may have subtly different flavors.
Question here.
Hello. Can you hear me? Yeah.
Yeah.
So the guy in the blue shirt, you said that, that's you, yes. You said that perhaps evolutionarily chilies are spicy to deter animals from chomping them down. But how would that sit with like sweet fruits, which animals obviously, well, me in particular, enjoy eating?
Yeah, I mean, I love a good apple as well. I think the argument has been that the way the seeds of these plants are present that actually they get ground up by the animals that tend to eat them. So there isn't actually a great big sweet core, sweet exterior as in an apple, which you'll eat and then throw away the core with the seeds in. These animals are actually destroying the seeds. But the birds somehow let the seeds pass through and distribute them without any damage. People have actually done experiments to show this, feeding seeds to different sorts of animals. So I think the idea that it's dissemination of the seeds through birds is quite a plausible one.
There's some mystery. I've got a chili plant outside at home. Nothing touches it.
Right.
I've got a chili trees in Colombia in the garden there. No plants, no animals touch them.
Right.
They'll have the apples, they'll have the oranges, they'll have the bananas, they'll have everything. It's maybe just the wrong sorts of birds,
right,
or something. But it's amazing. Nothing will go near them.
Right.
Okay. Any more questions? Okay, gentleman here and then the lady here.
Hi, I was just wondering, my question is related to whether there is a relation to reaction to spice and genetics. Because when I eat really spicy food, it makes my nose run. And when my grandfather eats really spicy food, it makes him sweat. When my dad eats it, nothing happens. So I was just curious if there's some relation there to genetics or if it's different to each individual.
Absolutely. I mean, there's a phenomenon called neurogenic inflammation where you go all red and so on when the nerve cells get activated, and capsaicin can definitely do that. And I guess it's interacting with other central pathways to get your nose dripping. But there are clearly remarkable individual differences in wiring, the expression of receptors and so on, not only gender-specific effects, but actually between individuals. And just to go back boringly to the pain topic again, this is the big problem with making drugs against pain, because everybody is so remarkably diverse in terms of subtle aspects of physiology, which is down to genetic variation, that getting drugs that will, be very good analgesics for a broad range of people is extremely difficult. Everybody is so different.
And sort of, I guess the different taste worlds we all live in should be partly determined by the genetics. That some number of us will be super tasters, so-called. Some number of us will be non-tasters. And half of us in this room will be medium tasters. Easiest to determine with a sort of a bitter tasting strip, which I have in my bag if you want to give one to your relations after today. And it primarily shows up in a different sensitivity to bitterness, but also your responsiveness to chili does vary as a function of the number of taste buds. So the more taste buds you have on your tongue, more likely you are to be called a super taster, and I guess show this kind of gustatory facial sweating response.
Okay, great. We had another question. Yep.
Forgotten.
You said, I'm sorry, I've forgotten your name. You work with Heston Blumenthal. Does he have perhaps desserts? Let's suppose a chili chocolate dessert of some sort. If you were, let us say, if you were to chocolate dip a chili, and of course it would depend on which chili, is this something that needs to be refrigerated? Would it be ground up and added to other things? How does this work?
I haven't seen such a dish. But if one was creating one, I suppose it might be a bit mean to hand somebody what looks like a nice chocolate with a strawberry in the middle, only to bite into it and get a chili heat. So one might want to grind it up and make it a bit more apparent, because that kind of surprise about oral sensations works when it should taste like this and it actually tastes like that. It's kind of okay, but when it's chili involved, maybe it's a whole different game, and people won't find it so funny. And like I say, well, probably you'd want to add the chili maybe more earlier on in the meal than later. Sometimes I've seen chefs who wanted to use it for its aphrodisiac properties. And again, whether that's best done at the start of the meal or the end, I don't know.
I'd actually like to expand on that.
Okay, well, that's we're coming to the end of the session now. I just wanted to perhaps ask the speakers to end by just saying in a minute or so what's the most exciting or interesting question in your field at the moment that you think we're going to see in the future of what you're working on?
Well, for us, obviously, we're desperately keen to make new pain-killing drugs. I mean, 50% of the population have a pain problem. It's increasing as we get older. 7% of people have a appalling untreated pain. You can't imagine the scale of the problem here. And so understanding things like the TRPV1 receptor, trying to tap into the mechanisms, block the activity of the nerves, you know, this is being used to some extent in the clinic at the moment. So anything, any natural product which we can taste or detect, which has some interaction with the pain system, is of very great interest to us, and we're very excited about this. We're particularly focusing on pain-free people. And actually, what I haven't done is check out whether they like Vindaloo's. I have to do this as soon as I get back in the lab on Monday. So we've got a whole bunch of people that don't feel pain at all. And so we found out the mechanisms that underpin this, and we're trying to make drugs that will mimic these conditions. But I never thought about the interaction with the capsaicin pathway. So maybe we can do something on this.
For us, it's kind of, I think, in the world of the music and taste interactions, and the thing that came out of this music compositions that kind of sounds a bit like Indian music, and what are the relations between the way recipes are created and the way music's created, and are these kind of develop independently, or is there some meaningful link between what goes on in a dish and what goes on in a musical concert in the place where that dish might be consumed? And there are one or two hints that, was it like I can't remember the title of the paper, which is one of my favorite titles, do Hindustani chefs make good musicians, or do Hindustani musicians make good chefs? One or the other way around. And this is kind of being revealed to us, or some answers being revealed by this kind of big data analysis where people put in all the recipes that are online anywhere in the world, and then look to see the sort of the flavor or ingredient pairing principles used in different cultures. And then when you find that in Western cuisine, we tend to pair ingredients that share flavor molecules, whereas in India, they tend to pair ingredients that share nothing in common at all. What implications, if any, does that have for how music might be composed, and then how the music that you listen to while you eat might come together?
Really interesting crossover there. Well, fantastic. Well, that's all we've got time for at the moment. I think do feel free to ask questions afterwards, but it only remains for me to thank our speakers, Professor John Wood and Professor Charles Spence, very, very much for their time. It's been a fascinating session, I'm sure you agree. So thank you very much. Thank you very much. Enjoy the rest of your evening.